All right, in this video, we're going to talk about center and spread. Typical measures of center are mean, median, and mode. The mean is known as the balancing point. So the mean is not resistant to outliers. If you have extreme values that are either extremely high, as shown in this picture, over here, these extremely high values, the mean will be pulled towards those values. The mean is affected by those outliers. And so the mean can be thought of if we give each value a weight equivalent to its the value of that data point, then the mean would be the balancing point between them all. The median also measures the center, but the median cuts the data set perfectly in half, with 50% of the data values on the left and 50% of the data values on the right. So it's the number in the middle. If you take all the numbers and sort them from least to greatest, count off lowest, highest, lowest, highest, lowest, highest, the middle number will be the median. The mode is the number that occurs the most. It's usually the first one we see when we look at a data set. The mode is unique because there can be one mode, multiple modes, or no mode, whereas the mean and the median, there will always be one of each. To calculate these measures of center, the mean is the average. It's written x bar, or sometimes with the Greek letter mu, and it's the sum of all the values divided by the number of values. So add them all up, divide by the number of numbers, and that is your mean. That is your average, that is your x bar. The median, abbreviated MED, M-E-D, is the middle value when the values are in numerical order. So you can put them in order from least to greatest, or you can go greatest to least, and then you count off lowest, highest, lowest, highest, lowest, highest, lowest, highest, until you get to that middle value. Sometimes there are two numbers in the middle, and if that's the case, we just take the median to be the number halfway in between those. So to find the number directly in between the two middle numbers, we take the mean, add them up, divide by 2, and that gives you the number in the middle of the two middles. The mode is the value or values that occur the most. Again, there could be no mode if each value or each number appeared exactly once. There could be multiple modes if a couple values appear each 3 times or each 4 times. And there could be a singular mode as well. The range is the difference between the least and the greatest values. So that word difference means subtraction. So we're going to subtract the largest number, the maximum, or the greatest value in the data set, and we're going to subtract the least number, or the minimum, or the lowest value. So the maximum minus the minimum is the range. Let's look at an example. We are given the population in millions in 2000 on each of the 6 inhabited continents. We've got 803 million, 487 million, 348 million, 3,686 million, 730 million, and 31 million. Our first question is, what is the range of the populations? So remember, range is the maximum value minus the minimum value. So we find the maximum, which is 3,686, and the minimum, which is 31, and subtract them. The largest minus the smallest. 3,686 minus 31 is 3,655. So the range of the populations is 3,655 million people. Next, we are asked to find the mean, the median, and the modes of these populations. So the mean, or x bar, or average, can be found by doing the sum. That Greek E-looking letter is called summation, the sum of all the x values divided by n. N stands for the number of numbers. So we're going to add up all the x's, all the values, all 6 of these numbers. We're going to add them up and divide by the number of numbers, which is 6. There are 6 numbers there. So here we are, adding up all 6 of those numbers and dividing by 6 to get 1,114 and some change. So the mean of the populations is about 1,014 million people if we round to the nearest person. Actually, million people. That's the mean. Add them all up, divide by the number of numbers. The median is the middle value when the values are in numerical order, or the mean of the 2 middle numbers if it's an even number. So let's check it out. We need them in numerical order. Notice for the mean, we didn't have to put them in order. We just added them up exactly as they were. For the median, we do have to put them in order. So you can choose least to greatest or greatest to least. But usually we write least to greatest because our number line has smaller numbers on the left and bigger numbers on the right. So ordering these numbers from least to greatest, 31 is the smallest, 348 is next, 487, 730, 803, and then 3,686. So put the numbers in order. Then we're going to cross off the lowest value and the highest value and continue doing that until we find the middle. Now, unfortunately for us, there was no number in the middle. We had exactly 2. So we're going to take both numbers in the middle and find what number is exactly in the middle of those 2. So 487 and 730, that's not very intuitive. If the number was like 16 and 18, I know what's in the middle of 16 and 18. It's 17. But these numbers are really big, so we can take the average if we're not quite sure intuitively what number is exactly in between these 2, by adding them up and dividing by 2. So 487 plus 730 divided by 2 is equal to 608.5. So the median of the populations is about 609 million people if we rounded to the nearest million. The mode is the number that occurs the most. There may be more than one mode, and the mode has to be a number that occurs more than one time. In this case, there's no mode. Each value is unique and it appears exactly one time. So there's no mode in this data set. Let's take a look at measures of spread. Spread measures how much data varies from the average, how spread out it is, how varied it is, how far away it is from the center. So the range we've already talked about is the max minus the minimum. That's the width of the sample. IQR interquartile range is the third quartile, which is actually just the median of the top half of data. So once you find your median, if you just totally ignore the bottom half and do your lowest and highest again with the top half, you'll get quartile 3, that Q3. If you do the same thing with the bottom half, find the median, look at just the values below the median, cross off lowest, highest, get to the middle, that's Q1. If you subtract them, that will give you the width of the middle half of the data, because you took the top half in half, bottom half in half, and then if you subtract those 2 values, that gives you the 50% in the middle. MAD stands for mean absolute deviation, and this is the formula for MAD. You're going to take each x value, each data point, subtract the mean. So m is another variable that represents the mean. Each value minus the mean, add them all up. This is the summation symbol again. Oh, I'm sorry, I forgot the absolute value symbols. Take each value, subtract the mean, take the absolute value of each of those, and then add them up, and then divide by the number of numbers, or multiply by 1 over n. Standard deviation is the typical distance between data points and the mean. If you look at a normal curve, it's a very popular, very common distribution. The inflection point, thinking calculus, where it turns from concave up to concave down, this inflection point right here at the top of this white line, that is located at the standard deviation. So there's a connection to calculus here. And here's the formula for standard deviation, which we're going to piece together or dissect piece by piece. So we're going to find the standard deviation of quiz scores. Here are the quiz scores. We have 18, 16, 19, 15, 17, 20, 20, 13, and 15. There are 9 values here. And here's our standard deviation formula. So to follow this formula, we're actually going to work from the inside out. We're going to start with the inside. This xi stands for each data value. So xi stands for each value in our data set. So those all our values. We're going to take each of our values, subtract the mean. Remember, x bar stands for the mean or the average. We're going to take every value, subtract the mean, square all those numbers, add them all up. This is the summation symbol. Add them all up, divide by the number of numbers minus 1. So 9 minus 1 is going to be 8. Divide by 8, and then square root our answer. So let's take a look at how that goes. 1. We're going to put our data. We're starting with xi, which stands for each data value. So we're going to start with our data. Then we're going to calculate the deviations. Deviations means how far. Like if you call somebody a deviant, they're like away from the norm or breaking the rules or off center or off kilter. That would be a deviant. So deviations are just how far away the data values are from the middle, how off they are from the middle, from the mean. And then squared deviations. So we'll fill in our data values. So 18 was our first data value, then 16, 19, I'm just rewriting this list vertically as the beginning of each row. So 18, 16, 19, 15, that just came from this list, 17, 20, 20, 13, 15. We're going to fill those in. Those are our data values. That represents our xi in the middle of this formula. So take each data value and subtract the mean. So we need to find the mean in order to follow this formula. The mean, remember, is adding them all up and dividing by the number of numbers. So we need to add up all these values and divide by 9 because there are 9 data values. And that gives us 17 as our mean. Following this formula, we'll take each value and subtract the mean. That's called the deviation. So the first one will be 18 minus 17. Remember, 17 was our mean, and that gives us 1. We're going to do that again. 16 minus 17, again subtracting the mean, gives us -1. You're going to see negative and positive values in this deviations column. We'll continue subtracting the mean from every single one of our data values and getting all of our deviations. We're going to have 9 deviations. This is how far away each data value is away from the mean. Now at this point, if we added up all these numbers, we're going to get 0 every single time because the mean is directly in the middle. So we should have an equal amount above and below. We should have an equal amount of positives and negatives. So adding them up at this point doesn't do anything for us. It should always give us 0. And if we're not getting 0, we've made a mistake. So every time you take data and you subtract the mean from each of the values, you should always get a sum of 0 for those deviations. You should always get kind of an equal amount of positives and negatives. And I don't mean like there's only 3 or 4 negative numbers, but if you add them up, it's equivalent to the sum of all the positives. So next we need to square the deviations. So we're going to take this whole column and square them. But if we took a little turn and instead of squaring them, instead of finding the standard deviation, this would be finding the MAD, the mean absolute deviation. So if we pause for a second with our standard deviation goal and instead found the absolute value of each of these numbers, that would give us the MAD. So the absolute value will just kill the negative. It will tell us the distance from 0 for each of these deviations. So we'll end up with +1, +1, +2, +2, all positive values and 0. And if we add all those up, check out the MAD formula. It says take each value, subtract the mean, find the absolute value of that, add them all up, divide by n. So adding them all up gives us 18. Then we divide by the number of numbers. There are 9 numbers, so we divide and get 2. The MAD, or the mean absolute deviation, is 2 points. So people scored on this quiz about 2 points away from the mean. That's what the MAD is telling you. Okay, that was a pause. Back to standard deviation. So we're not going to take the absolute value because that would be the MAD. Instead, we're going to square the deviation. So we're going to take each of these deviations and square them. Squaring means multiply it by itself. So 1 squared is 1. -1 squared is also 1, +1. And if we square each of these values, we're going to get all positive integers and 0. And when we sum those values, we're going to get 48. So we've taken each value, subtracted the mean, squared them all, and then added them all up. According to our formula, the next thing we need to do is divide the sum of the squared deviations by n-1. So we're on this part of the formula, dividing by the n-1. N again stands for the number of data values. We have 9 data values, so n-1 is going to be 8. We're going to divide 48 by 8, and that will give us 6. That 6 is called the variance. The variance is in units squared. Remember, we squared all of these deviations, so our units became units squared, in this case, points squared on the quiz. We added them up, we divided by the number of numbers, -1, and we got 6. So now the variance would be 6 points squared. But points squared doesn't really help us think about quiz scores, so square rooting that variance gives us the standard deviation. We're going to square root 6, and we're going to get 2.4948974278. If we round that, we would say about 2.4 or maybe 2.45. So the final answer is the standard deviation of the quiz scores is approximately 2.45 points. That means that the average distance that each score is away from the mean is about 2.45 points. Each person's quiz score is about 2.45 points away from the mean. That's what that standard deviation is telling you. Thanks for watching.